So the first thing we're going to want to remember when we're looking at graphing a function y equals f at x minus h plus k, regardless of what that function is. So recall it could be the quadratic function, it could be the absolute value function, it could even be the root function. So we're going to look at this as being the root function for this example. But if I look at this and I say that h is greater than 0, h is greater than 0 means it's going to be a positive value. When we sub that number in here for h, the way it's actually going to appear is y equals f at x minus some positive number, right? So x minus, say, for example, 3. Okay? Now we look at that and we might think because this is negative 3 here that h is negative, but it's actually not negative. H is positive in this case because we're saying that kind of, well, x minus whatever the value of h is. So if x minus 3, then h is 3. So, and if h is positive, then it's going to move to the right 3 units. Okay? Now what that means is that every single point on this graph over here, wherever we are, okay, is going to move 3 units to the right. So however many units that is, we're going to move that over, and we end up getting new points here, and we graph that. So really what we can say then is for our function mapping, like we showed in the first video, is that the point xy, in this case, notice nothing changes to the y coordinates, but something changes to the x coordinates. So when we take xy and perform the function mapping to x prime, y prime, we're going to take every single one of our points, but that's going to be, we're going to take x and y, and we're going to turn that to being x plus 3, or x plus h, and then y plus k, but since k is nothing, we don't do anything to those points for y. Okay, so hopefully that kind of makes a little bit of sense. Now, if we have the same type of example, except y is equal to, or sorry, h is less than 0, I'm just going to change my color here. So if h is less than 0, so for example, let's say h is negative 2. Okay, so we'll say it's negative 2. Then we would end up getting the equation y equals f at x minus negative 2, which would really show up as f at x plus 2, right? So here it looks like positive 2, like we would move it to the right, but actually we're subtracting negative 2, so x minus h is actually negative 2 in this case, which means it's going to move to the left 2 units. And so everything there is going to go to the left, to the left, to the left, and we would end up having, we'd end up having that function right there. Notice the y values do not change, only the x values do. So when we're looking at the mapping for this, it would be xy. Let me, I'm just going to move this really quickly because I'm not going to have the room. Oh, I'm sorry. I'm going to move this. I'm going to say xy here is going to map to x minus 2 y. Okay? So any of those values, you can take the original x values or the original points from the graph, xy, and then you just change them to being x minus 2, and then the y stays the same because k is nothing. So if we then look at the same thing with the k values, I'm just going to scroll up a little bit. Give a new equation here. So y equals f at x minus h plus k. Well, in this case, let's say we start off with being if k is positive. So is k greater than 0? Then we would say, let's say it's y equals f at x. We'll just leave h as 0 for right now. Plus 5. Why not? And I apologize, you might hear my kids in the background. Sorry about that. So if we look at this and we use the same function, the root function here, we'll start off with this and go like that. So that's our basic root function. And now k is equal to 5. Well, we're going to take our x value. We're not doing anything to it. But then we take that function value, which is y, and add 5 to it. So every single point here is going to move up 5, up 5, up 5. Now I know this isn't to scale, so I apologize for that, but So we move that thing up 5. But all the x values stay the same. So if we're function mapping here, and we're saying our points x, y are going to map to giving us x, y plus 5. Right? And we can do a similar piece there, where if k is less than 0, then we can say it's going to be, say, y equals f of x minus 2. Okay, that means these points will move down 2, down 2, down 2, and you graph your new function. Same shape, just move down 2. So we can say here that all of our points x, y are going to map to giving us x, because the x stays the same, but y minus 2. And this allows us to find all of our new points if we knew the original points on the graph. Okay, so here we can see that if k is larger than 0, it's going to move up. If k is less than 0, it's going to move down. Okay, so we'll just look at one last example here, and we'll say if we have y equals f at x minus 3 plus 7, then we should be able to look at this and say, all right, well, what's happening here? What's the h value? H here is actually positive 3. K is positive 7. I'm going to say k equals positive 7. So there, we should be able to now say that this moves right 3 and up 7. So if we're doing our function mapping, we start with x, y, and we're going to map to those new points. That means we're going to change our x value to be adding 3, and we're going to change the y values to being plus 7. Okay? So if we're graphing any type of function here, or if we have the graph of a function, I'll change our function this time to being, say, the root of x. So the absolute value of x, right? Then now we're going to say, well, we're going to move that, every x value is going to move to the right 3 and then up 7. So right 3, up 7. Again, not to scale, but this point here, right 3, up 7, new point. And then we can graph that there, do the same thing that way, and now you have your new function that's like this. And it's this exact same shape as this function here, except it's now been shifted to the right and up.